we will see about the control of ECF osmolarity. Now, what do you mean by osmolarity? Osmolarity is nothing but tonicity. Okay, so it is nothing but the number of solutes that is dissolved in the extracellular fluid is what is called as osmolarity. If it is given in milliosmoles per liter, we call it as osmolarity. If it is given per kg, it is called as osmolality. Okay, so those are the terms. So what is actually osmolarity? Is nothing but the tonicity. It is actually maintained by the solutes dissolved in the fluid. Okay, so which is a major solute here? We have got a positive ion, that is the sodium, which is the majority. Okay, accompanied by potassium, little bit of potassium is there, and then we have got anions which are accompanying this cations, bicarbonate and chloride. Okay, so together the sodium, potassium, bicarbonate and chloride, they form around 94% of the osmolarity. They contribute much. Okay, apart from this ions, okay, we have got glucose and urea. These are the organic compounds which are also present in the blood, that is contributing to the osmolarity. That contributes to around 3 to 5%. But since the urea is a highly permeable thing, it easily permeates into the cell and it contributes to the osmolarity to a little extent. So, it is quite ignored. Okay, so the major contributor is around 94% by the sodium. Okay, so this formula, total osmolarity, is directly proportional to sodium concentration plus total potassium concentration divided by the total body water holds good. Okay, so osmolarity is directly proportional to the concentration of the sodium, inversely proportional to the concentration of the water. That means when the ECF volume, water content is increased, osmolarity decreases. Okay, and vice versa. When the ECF volume decreases, osmolarity will increase. Okay, something called as ECF volume contraction and ECF volume expansion. When it gets expanded, then the solutes will appear to be diluted. Okay, when it gets contracted, there will be ECF concentration. Okay, so out of this, the sodium is the one which is the chief regulator of ECF osmolarity because it is a major cation. Okay, so around 140 to 145 milli equivalent of sodium per liter is there, and potassium is around 3 to 5 milli equivalent. Okay, this is the normal value. Right. Now, how can we estimate the plasma osmolarity based on the sodium? There is a formula given here. It is 2.1 into plasma sodium concentration. Okay. So, on an average, if you take 142 milli equivalent of sodium as a concentration, so we will calculate 2.1 into 142, which roughly corresponds around 298 milliosmol per liter, which is almost equal to this 300. Okay. So, out of this 300, please understand 298 milliosmol is contributed by the sodium, right. So, that importance is given to the sodium. So, if you maintain the sodium levels normally in the ECF, then automatically the osmolarity will be maintained and automatically the volume will be maintained. Sodium is the chief regulator for both osmolarity and the volume. Now, always remember, wherever the sodium goes, the water will also go. Okay, we will see that in the later slides. So, what are the mechanisms that regulate ECF osmolarity? These mechanisms predominantly regulate the sodium levels in the blood and thus it regulates the ECF osmolarity. There are two important mechanisms. One is the osmoreceptor ADH feedback system. The other one is the thirst mechanism. Okay. Now, what is this osmoreceptor ADH feedback mechanism? What is ADH? ADH is nothing but the anti-diuretic hormone, or it is also called as vasopressin. We have seen about this in detail in the previous lectures. So, what happens when there is increased osmolarity in the ECF? Suddenly you are consuming a full laced chips. Okay, so there is salt intake is greater in the chips. Okay, so what happens? There will be increase in the salt content. Immediately what happens? There will be increased vasopressin secretion that is produced or stimulated from the hypothalamus and the posterior pituitary. that goes and acts on the renal tubules so that water is reabsorbed by the presence of ADH. Okay, that mechanism can happen. So immediately after eating chips, what we will do? We will drink water, right? So thirst mechanism is operated parallelly. So that increases water intake. So what happens when there is increased osmolarity of the ECF? The water loss is prevented by increased ADH. At the same time, you have to add extra water to compensate for the osmolarity. So for that, there will be increased water intake. Water loss is prevented, at the same time water intake is increased. That's how the ECF is getting diluted and the osmolarity is corrected. Okay. So we will see about the osmoreceptor ADH mechanism first.